Hello everyone, welcome to AI Anytime channel. In this video, we are going to see that how you can quantize a large language model, that will help you run these LLMs on a consumer GPU or even on CPU. So I will show you that how you can take any LLM from the Hugging Face or wherever it is available in the open source, and then you can quantize that, in the GGUF format, so you can use that on your CPU machine. So in this video, we'll be focusing more on the conversion part of it, how we can convert an LLM to the GGUF format. Okay, and that's the agenda of this video. So let's quickly have a look at how we can do that. Now, if you look at here, I am on my Google Colab, and to perform this task, we are going to use a tool called Llama.cpp. Okay, now GGUF is interesting because if you look at these LLMs, large language models, having billions of parameters, it's very difficult to run it on a consumer GPU or a single GPU or even on CPU machines because to and generative AI or the LLMs in general will go mainstream if we can have this running on a CPU machine at a large scale. So the adoption is important on a CPU machine because not everybody has a GPU, where they can run it. So that's why it's very important to run it on a machine which have less computation power, and that's why we use these formats. GGUF is one of the format. It's an unified format. Okay, earlier we used to use called GGML. Okay, now we use GGUF had been converted, and you can see Gregor is creator of this format. We give credits to him. The reason he has worked on this technique. Now, it is one of the compressions techniques that we have been using when it comes to converting an LLM in a format that will be able to run it on CPU. Now, Llama.cpp is a very famous tool to inference large language model or convert these LLMs, and basically the right terminology is to quantize the LLMs. Okay, we are doing a quantization over here. Now, you can see I'm on Colab, I'm on V100. You can do this task even on T4 or even on a CPU machine as well, because I'm going to take a small LLM and then do that. Now, if you look at here, it's a git clone llama.cpp, and if you just expand this, you will see that we have cloned llama.cpp GitHub repository. Okay. Now within llama.cpp, we have many folders already that we are going to utilize. Some folders, some files, and things like that. Okay. Now I'll just make it a bit smaller. Now this is the next command. I have ran it already because it takes a bit of time. So when I'm talking, it will get completed. Now, if you look at what I'm doing, I'm going inside that repository that we have cloned, cd llama cpp, and then I'm using QBlast, which is a software. QBlast is a software. Okay. That helps you decide what kind of machine you are using, and then you can leverage that software if you are on a GPU. When I say llama QBlast equals 1, it means that I'm saying that, hey, look, I'm having a GPU which is running on a CUDA kernel, or that can be other GPU which have some compatibility with a llama CPP. Now, then I'm saying make that, okay, because you have to then make, and then I'm saying, okay, install requirements txt, whatever there inside the requirements, I'm asking to basically install that so we can work with llama cpp on the v100 GPU that we are leveraging probably. Okay, now you can see it's installing right now all the dependencies. Takes a bit of time, works on nvidia CUDA 12 plus version, and then we will do the next step. Now once you do that, I will just import Hugging Face. So from Hugging Face, hub import, and I'm going to use snapshot download, okay, to download the model from Hugging Face. Snapshot download, and I'll just wait to run it. Now we're gonna use QN 1.5 LLM. Okay, I'll just go on Hugging Face and search for that. Okay, so I'm gonna use QN in this video. Okay, and I can have a look at here. Probably which one? Okay, let me go here. You can use this model as well, but I think let's go with if you come over here, I will go with 1.8b. So let's take this LLM, okay, the model that we have, and then we'll push it on we'll first download this in the collab, and then we'll convert this will create a GGUF, a 4-bit quantized model from this LLM, and then we'll push that to Hugging Face, repository. So you can leverage it later with the Llama.cpp or C transformers or Cobalt or Uba, any other, tools or frameworks that you are okay to use. You can do that. Now, so let's copy this repository because we're gonna need this. And if you look at over here, it says you are connected to a GPU but not utilizing, blah, blah, blah. It takes a bit of time, guys, to make and then download all the required packages that we need to work with. Now, this is very important because recently we have seen different types of techniques, compression techniques and the architectures that the community is working on. So you would have seen one bit net, right? One bit computations, where we have seen that how basically it reduces the computation power when it comes to inferencing LLM and things like that, right? So there are many compression techniques that you can use to basically reduce the computation power of these LLMs, and GGUF being one of them. Okay, now let's just run this. We have we have many. Now, what I'm going to do is I'm going to define a model name. So let's do a model name. And this is also very important, guys, because most of the time we have to rely on the bloke on Hugging Face, Tom Jobbins, for example, because he has more than 6,000 models which has he would have quantized on his Hugging Face repositories. Now imagine if there is a new LLM coming in, or even if you are training or fine tuning something and now you want to quantize that locally, how can you do that? So I think this notebook will help you, this video will help you do that task as well. Now model name is done. Now for quantization, you can quantize up to 2 bits. Now, this is important, that what you want to do with this. So you want to go with 2 bits, 3 bits, and things like that. So what I'm going to do is I'm going to define methods, which is a list. So let me just do that. And when I'm doing this in a list, guys, you have to understand that you can pass different quantization. So you can do 4-bit, 8-bit, 3-bit as well in the same list. And once you do it, you will have different files created, the model weights files for those quantized models. Now, let me first do it for one of here. So what I'm going to do is I'm going to do Q4KM, the medium of 4-bit quantized. Okay, so let me just do K underscore M, and this is how, excuse me, underscore. This is how you define it. This is one of the method. But now, for example, if you want to do Q4K is small as well, then you can also define it over here, list it over here inside the list, and then those files will be created as well. Let me just do methods, and you can see I've done methods. Now, let's have a quantized path. So let me just do quantized path. Now here, what I'm going to do is let me just expand that. Now in quantized part, once the quantization is done, so let me just do uh, or before quantize, we need the base model to also download. So what I'm going to do is base model, and in base model, let's just have dot excuse me, original model or something. Now this is fine. Now we have original model, and then let's just close this folder. So original model, and quantized path will be same, that will be quantized model. Now this makes sense. Now let's just run this. So we are basically defining some constant where we will save our models. Now quantized path is done, base model is done. Now let's use snapshot download, because this will take a bit of time to download as well. Now snapshot download, and what I'm going to do here is I'm saying, hey, look, you use the snapshot download from Hugging Face and download that model for me. So what you're going to do is repo ID, and then in repo ID you're going to do repo ID, not repo ID, sorry. I have defined model name. So model name, and that is done. So the next is local directory, where you're going to save. So I'm going to save this in base model. And you can see it basically gives you in the documentation over here as well. You can see local dir, which is a string, and then gets the base model. And then I'm going to use symlinks, which you can see it's a Boolean value. So we're going to keep it false. True. Looks good. Now let's run this and see what we get here. Okay, now let me just run this. And you can see it started downloading it. So basically it will get some of the configs, tokenizer, JSON, and the model weights from Hugging Face for this QN 1.5 and the 1.8 billion parameter LLM that we are downloading it just for your reference, guys. There is no definition of a large language model when it comes to parameter. There is no thumb rule, but just for that's how you see in communities that any model, any language model which is greater than 1 billion in parameter, that then it has been called as large language models. Less than 1 billion, we call it as a language model, Flan T5, Lamini, and things like that, right? So just for that. Now that snapshot is done. Now after snapshot, what I'm going to do is let's have original model equals, and then I'm going to do quantized model. Quantized, it's not a model, it was a path. Quantized path, and then I'm going to look at FE16. Okay, so let me just do floating point 16 and then dot GGUF. Okay, now let me just run this original model thingy. Now we have to make that directory. So make directory and then make dot slash quantized model, and this is the directory we're going to create. And once you do this, you will see that there's a new folder called quantized model, uh, which is your new folder, and then we have original model. So in original model, you can find out all the models for QN that we have already downloaded from Hugging Face. You can see the safe tensors, which is the main model weights that we have downloaded, which is around 3.42 gigs over here. Now let me just minimize that original model thingy. Now once you have done that, we are gonna use Llama.cpp folder, and there is a file that I want to show you. We're gonna use this file, guys. Okay, if you look at over here, it says convert hf to gguf.py. This is the file that we're gonna use. Let me show you that file over here. Now they have done all the heavy lifting. So Llama CPP creators and the whoever contributors on the GitHub, they have done all the heavy liftings. They have created these files for you. So you can just leverage these files to basic. Of course, you can, customize this, make some changes according to which LLM you are using. For example, if you want to create for Phi2, which is a bit different the way we create when you compare this with llamas and mistrals of the world, right? So it depends on what kind of LLMs you are trying to convert or create a GGUF model from that, right? Now this is important. Now this is the file that we're going to use. You can see, we have a lot of things over here. It's a big file, and this is what I'm going to use here. Now for that, I already created some gist. I'm just going to copy that gist, okay, because it will take a bit of time to write this control A, control C, but I'll explain what we are doing, and I'll just minimize this a bit. Now, if you look at what we are saying, you're saying, hey, use the Python command and then, go into Llama CPP folder and then use this file called convert HF, which is Hugging Face. You can take model from Hugging Face to gguf.py. And then we have the original model folder uh, that we have, and then we have the output type, which is F16. Let me just come over here, out file, and then give the file name as fe16.gguf in this. So let's just run this now and see what happens. And you can see, it started getting it. It says special tokens have been added in the vocab. Make sure the associated word embeddings are fine-tuned or trained, things like that, right? It basically looks at all the block. It happens on the block level, zero and weight the weight, right? Now this is how it happens. Now it will take a bit of time, so let's just wait for it. This is important, guys. This is very important to understand that when you use GGUF, this is an algorithm is fascinating. Block-wise quantization algorithm. That's what they use it. Okay, there are two main types of quantization, 0 and 1. And in type 0, let me just see if this is working. Now in type 0 weights, W are obtained from quants using the formula. We just write it over here. Let me just write that in text. Now when you talk about type 0 quant, okay, these are excuse me, these are really fascinating topics, and this is how the weights are obtained. So if you have weights W, now just have to do W equals and then D, and then you multiply that with your Q. So D is the block scale. You can see there are n number of block. You can see block 9 attention, block 8 Q bias, Q weight. So there are different blocks in that. So what happens is that D is the block scale, and in type, let me just excuse me, the markdown format. Now in type 1 quant, it's a bit different. Okay, now how does that, the formula is on a very high level, W equals D multiplied Q, and then there is M. Now M is important. M is the block minimum when you do one type 1 quant, okay, which is a bit complex, I will say. And there are more performance degradation when you look at this route. But so there are type 0 quant, type 1 quant, and in the type 0, D is the block scale, and M is in type 1 is the block minimum. So zero or wall, whatever you use will slightly affect the size of the model and also the accuracy. See, guys, you have to be really, you know, it's very simple, right? In a way, when you quantize something, even they say it's a lossless compression. For example, when you have seen in your different projects, there are performance degradation. Okay, when you quantize an LLM, there will be trade-offs. Okay, because you are doing this for speed or you are doing it for performance. This is your call. Now, I think let's move on from there. Now let me just minimize this thingy. Okay, Llama.cpp, and then I will go into the next one. The next one is we're gonna just do the quantization now. So let me just OS, import OS, and then what I'm gonna do import OS is that for M in methods, I will have a for loop for M in methods, and then I'm gonna write Q type. So my quantization type F, and then quantized path, and then I'm saying you use m dot upper. So for m in methods, if quantized path upper should be a function, and then the GGUF. Now this is my Q type. Okay, now OS systems Llama.cpp. Let me just do OS dot system. mm, OS dot system, and then you llama, what's the command? Llama.cpp slash quantize. This should do quantize, and then you do quantized path, that is right, and then we're gonna do fp16. So fp16.gguf, and then you do plus q type, and then this looks good. Okay. Let me just have a look for m in methods, q type, f quantized path, m dot upper. Let's run this, guys, and see what happens. Now it might take up to a few minutes when you really quantize. Now, depending on how big your base model is, when I say base model, it can be pre-trained or fine-tuned, whatever. So the model that you are taking from Hugging Face, and once you basically quantize it, you can see that we have a model called Q4KMGGUF. So that model has been created. You can see it over here. You know, it's of course in the process of creating it completely, but you can at least see the model name, which is around right now it's around 249.1 MB, and this file will go up to around 1 billion or something. Now, let's wait for that. Meanwhile, I'll write the next piece of code where we can just try it out as well. So how you can try it out, they already have given you a file to try it out. So I'll just gonna copy this command from here. Don't have to write that lengthy, you know, thing. I'll just come back, and this is what I'm gonna. So if you look at over what I'm doing, I'm saying, hey, you go into that Llama.cpp main and go take my model, which is Q4KMGGUF, and then you have new tokens, then you have repeat penalty, you have some color for the terminal to get the output, and then I'm giving a file called, inside the prompt we have a file called chat with Bob. So it's a txt file. So basically it's ragging around that chat with Bob.txt. So basically looking at the context and the quantized model, and then you can ask some questions related to chat with Bob. So let's have a look at that. We'll ask that what is this document all about and things like that. Now this is what we're going to do over here. Now you can see it takes a bit of time, so we'll be okay with that. Now I will also show you that how you can push it. Let me open my Hugging. You can already open. Let me just go back over here. I need the access token, so I'm just going to come over here on access tokens, complete, basically copy this, and then I'll come over here and wait for, of course, wait for that. And then I will write the next piece of code, which is from Hugging Face. We have to log in into the notebook login. So I mean, we have to log in in the Hugging Face space now, and not notebook login, and then you just do notebook underscore login. And when you do notebook login, it will ask you to put your access tokens, and then we can paste your access tokens, and then just uh, get, I mean, you'll have the access to your dashboard on Hugging Face, your space completely, and you can push your models there. Okay, that's how it is. Okay, now you can see, let me just hover over it. Now if you hover over it, okay, you can see now the file has size has increased around 920 MB, and earlier it was 250 once we saw it a few seconds back. So our file size are getting bigger, and as we are very close to have a quantized 4-bit quantized media model of QN 1.8B. Okay, you can take any LLM. Every week there's a new LLM coming up. They are, coming up with LLMs every week. You can take any one of your choice and quantize it. Now you can see we have done the quantization thingy over here. It's around 900 or something. Now let me just run this and see, and it will give you a chat. You can see it says, hello Bob, hello, may I help you today? Please tell me the largest city in Europe, blah blah blah. I'm just gonna ask, what is this? Oh, I don't know. What is this document all about? Okay, I'm asking this question, and once I hit enter, you can see what is this document all about, and you can see Bob is now typing it. The streaming response, the token, which is fast, by the way. It's about an old friend of mine. Okay, let me just do it. Uh, the Please tell me the largest city in Europe. The largest city in Europe is Moscow, the capital of Russia. I'm going to ask, what is the capital of Russia? Now this is my question. Okay, what is the capital of Russia? Let's see. Yes, it is. So it's not giving you. Okay, now either the answer is wrong. Okay, it's basically yes, it is. It's given something. Uh, Tell me about Moscow. Okay, you can see now it's giving you. So Moscow is the capital of Russia, largest city in Europe, blah blah blah. Located in northern part of the Europe or whatever. Okay, northern part of the country. It's very big city and very important. You see, yeah. So you can see its output. We're getting the output, and it's fast as well. Okay, and we are just gonna pause this here. Okay, so now we have a Q4KM. Now let me just log in into this and put a token and log in. And once I do that, you can see login successful. So now I have access to my Hugging Face. I can push the model. Now I'm gonna push this so you can leverage it later on. Let's see later on how you can do that. Now from Hugging Face, and then I'm gonna do hub import, and I'm gonna use the HF API. Of course, this is right. I'm gonna use the Hugging Face API. I'm gonna use HF folder. HF, excuse me, this is right. HF folder and create repo. So I'm gonna use create repo and then upload underscore file. Okay, now let me just get this over here. Yeah, and now let's have our model name. Okay, so our model, not let's call it path. So our model path. So our model path is quantized model, and then our model is Q4 underscore K underscore M, and then I'm going to do GGUF. Okay, now this is my model path. Let's create a repo name. So I'm going to do is repo name equals QWin and 1.5 and then 1.8B, and then I'm going to do GGUF. Now this is my uh, repo name that I'm looking to create. Now repo underscore URL, the repository URL, and I'm going to use create underscore repo. Now create repo, and then I'm going to have repo name exist okay true, or let's keep it I'm gonna use private equals false. I want to make this public. Okay, so private, which is a boolean value, private equals false. Let's run this and see if this works, guys. Okay. Yeah, and now what I'm going to do is I'm going to say, hey, API equals, and then I'm going to use HF API, just initiate that, and we're going to use this API, and it has an upload file function. So that's what I'm going to use. So I'm going to say, hey, API upload underscore file, and inside that, let's do a few things. It says path or file object, which is like my model path, which is right. Then path in repo, which is, let's give this repo name because we haven't path in repo. No, that is different repo. So path in repo is like my model, which is Q4, because there can be other models as well. There can be other files. Sorry, not other models. There can be other files as well. Now you can decide which file to put. Okay, GGUF, Q4KM repo ID, and repo URL. Okay. Let me come back here on my, let's go to model. I want to see if there is a, what did I do? I didn't get it. New model. Oh, sorry. Excuse me. Okay. Now I'm just going to copy this. You can see there is no file right now. This has been created from there. You can see there's a Git attribute. Now this has been created 1 minute back. You can see from Colab. Now we're going to push our files over here. Now let's see how we can do that. Now to repo ID, this is my repo ID, and then I'm going to type a repo type. So repo type is important, guys. When you are using the Hugging Face API and the upload file, it supports different types of repo type. It supports your, model, it supports data sets, it supports spaces. So it depends, what kind of huge task that basically you want to do execute from this. Now let's push this and see. Now, what we are expecting that our model will get pushed and we'll have a quant. You can see now it's pushing it to basically Hugging Face, your Hugging Face account. Okay. Now, once you push that, you can use any tool like Llama.cpp again. You can do C transformers by Marella. You can find it on GitHub. You can use Cobalt, CPP, Cobalt. You can use others as well, guys. Depending on how do you want to do that, or you can do it through bits and bytes as well. It's fine. Now uh, once we do that, this is what I wanted to show you. So let's have a quick look on that. Okay. It will give you a commit info. You can see the commit message is upload Q4K and blah, 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 commit descriptions and things like that. Now let's come over here and then just do a refresh. Once you do a refresh, you will see that around 1.2 GB of quantized 4-bit model of QN has been pushed, to our Hugging Face. Now we have a model that, we can use this to basically, in C transform or things like that to basically use that. Maybe I'll show you in the next video or sometime. But I hope now you have enough understanding that how you can take any LLM from Hugging Face. Of course, you have to do a bit of changes depending on what LLM you select, and then you will be able to quantize an LLM and create a GGUF format of that, which is an unified format. Okay, you can use that to run this on a CPU or a consumer GPU. That was the agenda of this video, guys. I hope you like the video. If you like the content, please hit the like icon. If you haven't subscribed the channel yet, please do subscribe the channel. That helps me, to create more videos like this in near future. And this notebook will be available on my GitHub repository. If you have any doubts, feedbacks, thoughts, concerns, please let me know in the comment box. You can also reach out to my through my social media channels. Those information are available on channel banner and the channel about us. We also have a WhatsApp community, guys. It's growing really fast. We help each other, we learn from each other. So if you want to join it, please get the WhatsApp community link from the channel about us. Okay, that's all for this video, guys. Thank you so much for watching. See you in the next one.